Morning, students. This is Mrs. Jones. Today we're here to review how to convert binary numbers, decimal numbers, and hexadecimal numbers. These are the computer language of like the IT section of computers. So 4 pieces of vocabulary that we need to go over. First, a bit is a single pulse in a decoding system. A byte is 8 bits of information, so eight digits. A base is a number that is raised to a power, and then an exponent is how many times a base is used as a factor. These 2 vocabulary words you should actually know from Ascending School math class. Binary system is derived from base 2, so it's exponents of 2, 2 to the first, 2 to the second, 2 to the third. But there's only 2 options as digits, 0 and 1. The computer sees these as on and off. Using the information, we can build a conversion table similar to the one utilized in base 10 numbering. The base 10 is our normal numbering system. If you think about place values, we got the ones digit, the tens digit, the hundreds, the thousands, the 10,000s, the 100,000s, and so on. These are actually made from 10 to the 0, 10 to the first, 10 to the second, because there's 10 different options as digits in the decimal system. In the binary system, there's only 2 possible digits, 0 and 1, remember? So the place values are made by powers of 2. This is 2 to the 0 is 1, 2 to the first is 2, 2 to the second is 4, 2 to the third, 8, and then so on and so on. So these right here are the names of the place values in the binary system. And we're going to use those place values to convert the decimal number 231 into a binary number. So what you do is you take your calculator. So I'm hoping that everybody has a calculator either on their screen or a handheld one. And you take your decimal number 231 and ask yourself, can I subtract 128 from that? Yes, I can. So I'm going to do that operation on my calculator, and I'm going to put a 1 in that spot. On my calculator, it should now say 103. Can I subtract 64 from that 103? Yes, I can. I'm going to put a 1 there, and I'm going to subtract 64. I get 39 on my calculator. So now 39, can I subtract the next digit 32? Yes, I can. So I put a 1, and I actually do that on my calculator. My calculator now reads 7. Can I subtract 16? No, I cannot. From my 7, can I subtract 8? No, I cannot. Would I be able to subtract a 4? Yes. So I put a 1 and actually do it on my calculator. My calculator now says 3. Can I subtract 2 from that? Yes, I can. And then I'd be able to subtract 1. So the binary number 111001111 represents 231 in binary numbers. And the way that you would go back is that these ones mean yes. So you would take all of these 128, 64, 32, 4, 2, and 1 and add them all back together, and they should get you back to the 231 decimal number. Let's do another one. So same process. You start with your 201 and you say, can I subtract 128? Yes, I can. So I'm going to put a 1 there, and I'm going to actually do that on my calculator. My calculator reads 73, so can I subtract the next place value? Yes, I can. And then I actually do it on my calculator. My calculator now says 9. So I can't subtract a 32, I can't subtract a 16, but I can subtract an 8, which brings me down to 1 on my calculator. So that means I can't subtract these ones, but I can do the 1. And again, if we wanted to go back to the decimal number, we would just add all those place values together. So a third example. So you can't subtract 128, but you can do a 64, and you could do a 32. Remember, this is riding the whole way through your calculator. This is what you get when you go through your process. And again, you add them all back together to get them back to the decimal number. So our fourth example, from 56, you can't subtract a 128, you can't subtract a 64, but you could do a 32. So yes, you do it, and you do it in your calculator, and you get 24 in your calculator. Can you subtract a 16? Yes, you can. Then can you subtract an 8? Yes, you can, and that brings you down to 0, so the rest of these are all zeros. If you then add your digits back, or your place values back together, it'll get you back to 56. So that was the binary system and how you do conversions with the binary system. The hexadecimal system is a little bit different, kind of. These numbers are to the base 16. So the place values are based off the exponents of 16. And the possible digits are 0, 1, 2, 3, 4, 5, 6, 7, and 8, and 9, and the letters A through F. So this is how it lines up. In a decimal system, in a hexadecimal system, a 1 is a 1, a 2 is a 2, a 3 is a 3, so on until you get down here to 10. A 10 in the decimal system is an A in the hexadecimal system. And an 11 is a B in the hexadecimal system. 12 is a C until you get down to 15. That would make you have 16 digits. So we're going to talk about how to convert from a decimal number C3 or a hexadecimal number C3 to a base 10 or to a decimal number. So you look on your chart and you say, well, C is 12 and a 3 is a 3. And then you take those times. So this 12 is going to be times 16. And the 3 is going to be times 1 because the place values in the hexadecimal system are 16 and 1. So you use this little chart, or once you do this a number of times, you're going to be able to memorize that. And you find out what these two digits are equal to in the binaries or in the decimal system, and you multiply those by 16 and 1. Let's look at another example. So a 4, this is convert the hexadecimal number 46. And how you're going to know that this is a hexadecimal number is that it'll have a little teeny tiny 16 written right down here at the bottom. It doesn't, I couldn't get it to do it on my PowerPoint, so it's not there. But the hexadecimal number 46 to a regular decimal base 10 number. So a 4 is a 4, right? And a 6 is a 6. Getting that off of the chart over here. And then we're going to multiply the 4 by 16, and the 6 times 1 tells us that the hexadecimal number 46 is actually 70 in our regular numbering system. Okay, So now we're going the other way. This is converting the decimal number 126 to the hexadecimal number. So what you're going to do is you have to do a little bit of magic on your phone, on your calculator. You do 126 divided by 16, and that's going to get you a decimal. The decimal is 7.875, but we're only concerned about the whole number 7, okay? And then you got to figure out what the remainder is. A way to do that is take 7 times 16 and work it backwards. 7 times 16 is 112, which then if we subtracted that from 126, we'd get a remainder of 14. I'm hoping that everybody can kind of follow that. Your calculator will not tell you what the remainder is. You've got to figure it out. So then you look at the chart and you say, well, a 7 is a 7 in the hexadecimal system, and a 14 is an E in the hexadecimal system. So that makes the hex number 7E is equal to 126 as a decimal number, base 10 decimal. All right, let's do another one. Okay, so we're converting the regular base 10 number 144 to a hexadecimal. So we're going to take 144 and divide it by 16. Ooh, we get just a plain 9, and there's no remainder. There's a remainder of 0. So we look at the table and say a 9 is a 9 and a 0 is a 0. So the hex number would be 90, and the way that you would write that is you put a little teeny tiny 16 here in the bottom right hand corner to signify that that's a hexadecimal number. I hope this helps you understand how to do the conversions between the binary base 10 and hexadecimal base 16. The last 3 slides, remember, were extra information. The bulk of the information that I want you to know came from the slides toward the beginning. Please answer the questions on the Google quiz, do your best, and if you have any questions, please email me. I hope you have a great day and take care of yourself. All right, see you next time. Bye.